Good afternoon, everybody. Welcome to today's colloquium of Physics Faculty, University of Warsaw. Our guest today, the lecturer, is Rafał Grabiański, who will tell us about Science in Space, a summary of major scientific research activities. He is a graduate from Informatics, Electronics and Telecommunication Faculty of the Kraków Academy of Mining and Metallurgy, works now for IBM, but his great interest from his teens actually is cosmic research and rocket technology. He was a blogger in this area also. 6 years ago, he joined the team of Urania Postępy Astronomii, Advances in Astronomy, a bi-monthly, which is devoted to dissemination of astronomy science. Urania actually is a product of a fusion of two scientific journals, and at least one leg of it dates back to 100 years ago, 1922. Rafał writes text on rocket launches, cosmic missions, satellite technologies, and many other. All in all, we shall have a lecture delivered by a space science enthusiast. Rafał Grabiański, please, the floor is yours.
Thank you very much. I will just share my screen. Just please confirm to me if screen is visible.
Yes,
by you.
it's visible. It is full screen.
Oh, right. So finally we made it. Yeah. Okay. So thank you for your introductions and welcome everyone. As I was introduced, my name is Rafał Grabiański and I am editor in Urania Postępy Astronomii. Basically, my work is focused on space, our web portal that was created some time ago, but I also sometimes write to our magazine, and as it was mentioned, this is the oldest magazine, astronomical magazine in Poland. So one of its branches dates back to 1919. And yeah, and we publish till that day. Currently, our focus is both on astronomy, but also on space research. And I am more interested in that second area, which is space research. However, of course, I am surrounded by astronomers there and astronomy enthusiasts, so I also can learn a lot from them. And actually, I have ambition that maybe if time, of course, permits, to pursue at least a master degree from astrophysics. Maybe it will come in the future, in the near future, I hope. So as I said, Urania is currently published every other month. You can order subscription of it, buy it online, or get it from some press shops like Empik. We also have a website, and this basically my history of Urania is like I joined 5 years ago in 2017. Our news portal started in 2012, so 10 years ago. And just to sum up this interest that I have in astronomy and astronautics, I was running a blog about Mars exploration. It was when I was in the middle school. There was a very interesting time in the space industry because the space shuttle program came to an end. It was closing. Last space shuttle missions were run, and second thing was that Chinese developed a crewed program. Actually, this crewed program was developed many years earlier, but during my time there was initiation of first prototype space station by China. So that's what get my interest, and that's how I get interested in rocketry and in space to that level that for one time I thought that I would be going to study at Warsaw University of Technology in the faculty when I can learn about aviation and rocket science, but finally I chose more pragmatic thing that I became a software engineer, and well, I thought that by being a software engineer I can work almost in every domain, so that's more elastic for me. So yeah, that's just a brief introduction of me, my interest, and now let's go to the meat of this presentation, which is space missions and what currently happens on space. So my aim here is to show you how science fit into space industry currently as a whole. You will know after this presentation how many space launches are made every year, how many of these space launches is actually related to science, or its only aim is to send science mission. And we will talk about current major scientific projects in space. Which is, of course, International Space Station, solar system exploration, Mars exploration in particular, and moon exploration. Moon is coming to be again first objective for United States and for China. So that's when we will also focus a little bit. I will talk about what can be done on space station, what is currently being done there. Maybe if time permits, brief talk about James Webb Space Telescope that is already in the alignment phase. Actually, optical alignment finished recently and all instruments are working now fine, but we are still waiting for science data to be gathered. Probably it will come between June or July. Yeah, so that's the outline. So let me start by talking about rocket science and actually not rocket science, but rocket industry in general, how it looks like. This chart that you see on this slide shows the number of successful orbital launches made by different countries in the world in 2021. So as you see, we have like two main space powers. This is China and USA. It's for recent years they are exchanging between first and second place, and their launches they launch majority of orbital flights nowadays. Third place is Russia currently, but this will definitely change. After Russia invasion, all commercial clients, actually they haven't got many commercial clients now after space commercialization in the United States, but even after this, this will be like almost done for the Russia. Russia will only send satellites for military and for International Space Station and mission for International Space Station. Europe was on the fourth place, which is very good sign because there is a significant decrease of launches by the Europe. And we have some other countries that also have these orbital launch capabilities. This is Japan. They were second power in Asia. For that, there is of course India. Actually, India had very bad year last year because of the COVID. So COVID disrupted their space industry significantly. It will be much better in the future because typically India launches about 5 to 7 orbital launches per year. We have also Iran, South Korea also developed their own rocket systems. They actually first were doing that with Russia, but currently they have developed their own launcher systems. So what that graphic says to us? Actually, we have now time that the number of orbital launches is in record high compared to the past decades. That many launches were previous time possible in 1970s, actually at the end of the 1960s, when there was many launches, but the reliability was much lower. The reliability of these rockets was much lower. What drive that increase currently? So we have like 4 main reasons for that. First is this all new space industry. And thanks to miniaturization of electronics and of many satellite components, it is possible now to build much compact satellites, much smaller satellites that can do the same job as was done in, for example, 90s with few ton satellites. So that's one driven factor. The cost of building satellite is much lower than it was several years ago. The second thing is the demand for mega constellations. We will see if it's not a bubble, because I have in my memory example of Iridium space. This was Iridium constellation. This was constellation of telecommunication satellites that were to provide mobile communications. And when they started in the 90s, actually people thought that this satellite mobile communication will be better than phone, that typical phone based communication that is based on the base station that are built on the ground. It was because this ground communication was not very efficient, and there was not so many clients of that, so the infrastructure was pretty poor. But finally, Iridium filed for bankruptcy. So this is the sign that not every space project will be economically feasible in the future. So we will see how it gets with the Starlink constellation. Probably many of you heard about this. We have already thousands of satellites sent to low Earth orbit, and that currently serves about 200,000 of clients in the world. It's even possible to order that communications, that internet from in Poland, actually. Basically all Europe countries have already permissions for that. Next thing is better access to space. So rockets are cheaper now. We have companies like SpaceX. We have many rockets in China that are more modern than the previous ones, that are cheaper. We have India, we have Europe that develops their own systems. The rockets are much cheaper. The flight to orbit is much cheaper, and that allows for more companies to join this market. Okay, so to sum up, 146 orbital launches in 2021. Most of them, 70, were carried by government. 27 were carried by commercial companies, but under government contract, and only 49 of them was done by commercial companies and for commercial clients. So as you can see, still majority of orbital launches are run by government money, so by taxes. The most popular rockets nowadays, these are 3 that are most popular. Of course, Falcon 9, this is SpaceX rocket, American company. It's the cheapest one when we count kilogram, how much you need to pay for the kilogram to put into orbit. It made 31 flights last year. Second one is Soyuz rocket families. This was mainly done for the International Space Station missions, but also some military and some commercial launches for Russia. And the third one is Long March 4B, 4C family. So this is one of the most popular Chinese rocket that is currently run by China. Most popular satellite use cases that we have nowadays. So first of all is telecommunications, big internet networks, military communication, ship air travel communications, emergency warning, TV, radio. All that things still counts as majority of orbital launches and satellites that are sent to orbit. I think second is military satellites. So apart from communications, we have signal interception satellites. So the satellites here for electronic frequencies, and they try to identify, for example, vessels from Navy, from also air travelers. All these things is getting intercepted and identified. Spy satellites, of course, so Earth observation with very high resolution. Also early warning systems, so the systems that allows big countries like United States, Russia, or China to recognize if some other country launch ICBM to them. So these systems are basically able to recognize such launches in a matter of seconds and also recognize their trajectories, and they are of course integrated into the all defense system that that allows to intercept such missiles. Apart from military communications, we have of course crewed missions. So now 2 space stations are in low Earth orbit, Chinese space station and International Space Station, and many missions are provided to them. So we have crewed missions, but we also have cargo missions that are about twice as frequent as crewed missions. And this cargo is of course scientific research cargo, but also food, clothing, and all supplies that crew on this space station needs. Next, we have weather and science satellites. So we have weather satellites that are focused on weather, not only Earth weather, but also space weather. And we have, of course, science satellites. So all this solar system exploration and satellites that, for example, make research about our sun. These are next category of space launches. And we have final last but not least, commercial Earth observation. This is the market that is developing, I think, in the fastest ways, apart from communications, apart from internet constellations, because we now can have very small satellite that can achieve resolutions about 1 meter per pixel, or even half meter per pixel. So we can launch many satellites like it, and we can have revisit time about 6 hours. So we can have basically every part of the world covered every 6 hours by such satellites. So we have like Earth observation, of course, in the visible domain, but also we have radar constellations like Polish-Finnish startup ISI, which is developing constellation of radar satellites that allows to make Earth observations no matter what is the weather. If there is cloud cover, if there is night, if there is day, they're able to do that. So let's go to science, because this is the title of the entire presentation, what science is done on space. In 2021, we have very interesting year in space. As you can see, for example, reading our magazine or portal, we have launch of James Webb Space Telescope, which was probably highlight of this year, not only in space science, but I guess in space. Remembering what Hubble Space Telescope did to science, we hope that Webb Space Telescope, if it will be working fine, will do at least the same amount of work for the scientists. We have also Year of Mars, because there was the time when the probes that were sent 2 years ago were arriving to Mars. We have every 2 years most efficient time period when we can send probes to Mars, because of course planetary alignment. So actually 3 missions came to Mars. First was maybe I won't tell what was first to not insult everyone, because I don't remember, but I think that the United Arab Emirates were first with the Al-Amal mission. This is only orbiter of Mars. Other mission was Tianwen-1. This is actually first Chinese mission to Mars. China wanted to send a probe to Mars in 2011. It was very ambitious. It was a mission that was going with another mission, very ambitious Russian mission that wanted to get some samples from Mars Phobos moon, but it was stranded on a low Earth orbit. And so also this Chinese payload didn't make to Mars. But Tianwen-1 was a mission made only by China, and it was very successful. It was their first try to Mars, and they made all things good, like landing on the Mars with their lander, roving on the Mars, and rover is still active, and also have their orbiter that their mission was planned for 1 year. It's almost over 1 year. The rover was planned to work for 90 days, and it's or even for 30 days, but it's still working. So also over 1 year of work. And finally, we have NASA Perseverance Mars rover. This is the second big rover sent by NASA to surface of the Mars. This is like one ton of a mass. Yeah, so we had like 3 missions. I will talk more about them later. Actually, more about Perseverance Mars mission, because we have more the most data about this mission. We had also launches of some telescopes, so some smaller telescope. So there was launch of IXPE, NASA Imaging X-rays Polarimetry Explorer. This is not very big space telescope, but very important for astrophysics. Its aim is to improve polarization sensitivity by 2 orders of magnitude compared to the other space telescopes. Of course, these polarization measurements are important for some of the astrophysics research, like, for example, recognizing geometry of magnetic fields around magnetars. There is hope that from the data from this telescope, we could have help with finding mechanism responsible for X-ray production in pulsars. So all that things can be made possible by this small but very fancy telescope. We had also in 2021 launch of Chinese solar telescope, so first Chinese telescope that is dedicated to solar observation. And it is tuned to monitor sun in the hydrogen alpha spectrum. So in this spectral line, we will be able to observe solar flares. So these giant eruptions that send huge amount of radiation into space. Process that drives these eruptions is still quite mysterious. So we will see what they will find with the data of this telescope. We have also some other missions like oceanography, satellites, of course, planetary missions started in 2021, like 2 NASA missions. Mission Lucy, that is first mission to Trojan asteroid around Jupiter, not around Jupiter, but orbiting like Jupiter in their liberation points. In its liberation points. So this is one mission, and the second is a DART mission that is very interesting because it's actually testing of asteroid defense. So this mission will go to near Earth asteroid, and it will purposefully impact it, and we will check how this impact will change trajectory of this asteroid. Of course, this asteroid is not a risk for us currently, but we will see if that way we can defend a bit before such event can finally happen. We have also Osiris-Rex mission that gets samples from the Bennu asteroid. This returned to Earth actually in 2021. And this is the mission that was studying C-type asteroid, so very dark, containing large amount of carbon, and it's like 75% of asteroids are of this type. But still, we didn't have a mission that brought samples from such asteroid to Earth in big amount, and this mission allowed that. Also, this Osiris-Rex probe studied non-gravitational effects on asteroid trajectories, like Yarkowski effect. This is effect caused by thermal emissions from the asteroid. And this thermal emission is anisotropic. It has quite a huge effect over time in orbit prediction. So even if we observe asteroid for a long time from Earth, we still have some error because of these non-gravitational effects that we cannot predict in very long future how this asteroid will behave. So that's very important to know these mechanisms better. Here I'm only listing the solar missions that are currently active, and I will not talk in detail about them, but you can see only to get the big picture how many solar missions are currently active, run by different space agencies. So we have like 4 missions currently active in the Moon. We have 2 missions for the Mercury. Actually, sorry, Bepi Colombo is for the Mercury, Akatsuki is for the Venus. We have a lot of missions in Mars. The oldest orbiter is from 2001, Mars Odyssey. We have 2 European orbiters, Mars Express, ExoMars mission. We have on the surface missions Tianwen-1, Mars 2020. We have InSight lander that is measuring seismic waves on the Mars. So a lot of them. Still Curiosity rover is working fine. So there is a lot of missions. We see that Mars is very demanded by scientific community. We have also missions to planetoids. Hayabusa 2 was Japanese mission. Osiris-Rex, I said that this mission returned, but actually samples returned. The orbiter that brought these samples to Earth was not burned in Earth atmosphere, but it was repurposed, and its mission is to study some asteroids after this Bennu asteroid. As I said, in 2021, Lucy and DART mission started. They will also be studying planetoids. We have 2 SAL missions, Parker Solar Probe and Solar Orbiter. Parker Solar Probe is American mission, the Solar Orbiter is European mission with the help of Americans. We have also outer planets probes like Juno. Juno mission was to be ended a few years ago, but it's still researching and it's still studying Jupiter system. We have, of course, New Horizons mission that made flyby from the most distant object in solar system, and of course we have Voyager 1 and 2 still working and still sending radiation data. Okay, let's go to Mars, because this is the most interesting destination for at least for the planetary scientists, apart from Earth, of course. So Mars is a main destination for solar system missions for years now. As you probably know, it was long thought to be a twin of Earth. And when you go to the oldest issues of Urania Postępy Astronomii, actually Urania magazine, you can read in these oldest issues that there were some divagations about whether there is life on Mars in 1920s, whether these canals that are visible by the telescopes are made by some civilization. And still in the 60s, there was a big belief that maybe not civilization, but some simple form of life can be possible and can exist currently on Mars. So we have first successful mission to Mars, which was Mariner 4 in 1965. And this mission showed that Mars is very much like Moon, a cratered world without any plants or something, or canal created by civilizations. Not any of it was visible from the photos that Mariner 4 brought to Earth. So in 1975, there was two landers, Viking 1 and Viking 2, that landed on the surface of Mars. Earlier, but because in 1971 there was a Soviet mission, Mars 3, that landed as first probe successfully on Mars, but it only worked for 20 seconds. So after 20 seconds, it started working and it didn't return even a single full photo. But historically, Viking landers were not the first that successfully landed on Mars, but Vikings were definitely the first missions that brought big science data from Mars back to Earth. And these missions also had some science payload that was dedicated to research for life on Mars. Still, there are some scientists that says that the results of this lander data, the lander data is not conclusive. So there are still some scientists that believe that some of this data indicates some organic compounds created by life on Mars. And still this vision of life on Mars, of past life on Mars, is existing in scientific community. And the biggest sign of it, that we still think that maybe one day in the past there was some simple form of life on Mars, and the sign for it is the missions and the money that goes to these missions and their objectives that these missions have. So we have a Curiosity rover that landed on Mars in 2012. It landed in Gale crater. And the mission had objective to find whether on the surface of Mars there was environment, there was conditions that supported life in the past, that could have supported life in the past. And we actually find it with the Curiosity rover. We found evidence of persistent liquid water on the surface. Actually, this was done in very beginning of the mission, because we found some rocks that indicated sedimentary rocks that indicated alteration by water. We found also suitable chemistry in the past, so organic compounds, all organic compounds that could have supported such life. We found some local methane anomalies. And about methane, it's very interesting for the media, because on the Earth, methane is very associated with life and with some forms of life. So that's why it's also very loved by the media to talk about this methane on Mars. But actually, there are a lot of geologic processes that can also be responsible for these methane anomalies on the surface of Mars, and we still don't know what brings these local methane spikes in Mars atmosphere. It's very, very mysterious, and we have actually one dedicated mission, European ExoMars Orbiter, Trace Gas Orbiter, is actually doing mainly that. So it is purposed for finding this methane in the atmosphere. Curiosity also did that and found such local anomalies. Thanks to Curiosity, we have now long-term data of surface radiation levels, because it has such a scientific payload that allowed to doing that. And from not scientific achievements, but very technical ones, by Curiosity rover, we were able to prove that we are able as a human to land 1-ton class rover on the surface of Mars, which is not very simple task. It's actually very, very difficult to land such rover. And if we think about the future, about future human exploration of Mars, which is many years ahead, it's not possible to do that now. But if we think about it, we would have to have technologies that allows to landing 30 tons on Mars, or 50 tons. So as you can see, this we hope that we will finally be able to do that. But this 1-ton was already very big achievement. We also proved by Curiosity rover that we can have high precision of landing. It was within 20-kilometer ellipse. We also demonstrated technology that allows for the long and remote travel of this rover. So Curiosity rover was the first rover that was equipped with the software that allowed autonomous driving on the Mars. It was not used very often. So the next rover, Perseverance, is highly using it, but still Curiosity was the first, was the pathfinder for that. Okay, and we have next rover now on Mars, second big rovers that have almost the same construction. This is Perseverance rover that landed on Mars last year. So Curiosity, its main aim was to find whether Mars have environment that supported life in the past. Perseverance goes one step further. It is a mission that its main scientific objective is to actually look for such signs of past life. So look for biosignatures. And the second main objective of Perseverance rover is that it is preparing samples on the surface of Mars that will be in the future brought back to Earth. So Curiosity was actually in the formal scientific papers called Mars Science Laboratory. And it was called like that because this was really a mobile laboratory. The entire body of this vehicle was filled with chromatography, with laser spectrometers and stuff that was able to study rock samples in place, in situ. So Curiosity rover was doing that, and Perseverance rover doesn't have that. Perseverance rover, instead of this mobile laboratory, have a sample acquisition system that allows to containing rock samples inside tubes, closing that tubes and leaving that tubes on the surface of Mars, so that the next mission that will come at the end of this decade will get these samples and bring it back to the Earth. So that is the next scientific objective of Perseverance rover. And the technology one was the technology demonstration of autonomous flying in Martian atmosphere. And we proved that actually we can do that. So we can have autonomous flights on in the atmosphere of the Mars. And this atmospheric flight proved to be so good that it was this small drone was repurposed. At first, it was only a test of technology, but now this Ingenuity drone is actually scout for Perseverance rover. So it is used to search for next places to go to for the Perseverance rover. Okay, so briefly, let me talk about the architecture of the landing, because these two rovers have very similar architectures. And it used a rocket backpack to allow this landing. So we have like 3 phases of flight. Atmospheric flight in the shell. So that's where the most of the energy is dissipated through the thermal drag. Second, we have rockets, and third, we have we have between them we have also parachutes, supersonic parachutes that are also very difficult to develop. And after supersonic parachutes, we have also rocket landing. So we have 3 technologies combined together to allow putting that single rover to Mars. So if some of you didn't see that, I really encourage you to look for the films how it looked like, because Perseverance rover actually had cameras on board that allowed to look how it looked like, not on the animation but live on the surface of Mars. Thanks to Perseverance rover, we were able to still decrease the ellipses of the landing, thanks to technologies like machine learning. and ability to make relative navigation, autonomous relative navigation on Mars. This allowed to be very precise with the landing, and this allowed for the geologists to choose the landing site that was much more dangerous, because scientists were very limited for previous Mars missions, because engineers told them that we need to find ellipses 20 kilometers wide that has no very big obstacles, that the probability of failing because of landing on some rock is very low. But now, thanks to that relative navigation systems, we could have a map that allow us to land very precisely on the terrain, to have recognized some dangerous areas and just divert from them. So thanks, I have entire presentation about that, so I won't tell much about it, but it's really amazing system that was developed, and amazing that technology allowed us to do that in such short time, because between planning of the Curiosity rover mission and Perseverance missions, it was like 1 decade only apart. So it's amazing how it was done. Here you can see the map of safe sites that were written in actually pre-recorded for the software of Perseverance rover, and basically this algorithm looked like we have photos of surface doing every 100 milliseconds, and based on that photos we recognized where the rover was during their flight on parachutes and then on the rocket backpack. And after we established where we are, this algorithm choose the closest green dot that is safe for the rover to land, and it sent parameters how these rocket engines needs to behave to just go to that place. And it went perfectly fine. We did that. So let me go to the next slides. Here we see one of the first, actually the first color photo done by the Ingenuity Mars drone, and we see that this was flight I think about 5 meters tall. It was the color camera was turned on the second flight. Now I lost track how many flights this Ingenuity drone did on Mars, but I think it's over 20. And what's more amazing, it was not engineers were not able to fully test this Ingenuity drone on Earth, because the flights that is now this drone doing is like sometimes flying over 50 meters or even 100 meters across Martian landscape, and we don't have such big places where we can vacuum. We can have vacuum chamber that allows for such big flights. So on Earth, of course, this Ingenuity drone was tested on the biggest vacuum chamber available on Earth, but still it was only able to fly maybe for 1 meter across. So that's big engineering achievement that we are able to do that in first try. This is one of the payloads that is also brought by the Perseverance rover. This is the MOXIE generator. It's actually first sign that we think seriously about making crew mission to the Mars, because this is oxygen generator. It creates oxygen from electrolysis from the carbon dioxide in the Martian atmosphere. It can make about 6 grams per hour of this oxygen, so it's only for the testing purpose. It's not it won't be useful for the crewed mission, but yeah, people at NASA and other space agencies knows that if you want to go to the Mars, we need to be at least self-sufficient. So we need to generate our own oxygen for breathing. We need to generate water. We need to generate oxygen for the flight back to Earth, because it will be impossible to bring such mass to the surface of Mars. So this, I know that this payload was powered on at least one time, and it is successfully created oxygen. It won't be powered very often because it requires a lot of energy. It generates about 800 degrees of Celsius to do that electrolysis, but still it will be run at least several times to check for the different atmospheric conditions on Mars. Okay, and second biggest program that I would like to talk to apart from Mars is the Artemis program. This is the program that we plan to go back to the moon. And now, as of now, it's planned that the first crewed mission to the surface of the moon will be in 2025. Of course, this is very optimistic and it won't happen, I can tell you now, but this fast track approach maybe will allow us to go to the moon or in 2028 or before 2030. So this is a NASA program, but
I have 10 minutes to the end.
Okay, so I will be going to the end. So this program is done by NASA, but actually with the international collaborators. So Europe, Canada, Japan also take part in this program. Main components of this program is the SLS rocket, so the Space Launch System. It's a super heavy rocket developed by NASA with Boeing. We have Orion spacecraft. This is the deep space spacecraft, first deep space spacecraft after Apollo. And we have also human lander developed, this Starship that is developed by the SpaceX. This shiny vehicle is meant to be the first lunar lander for the humans. Of course, there is also ground support equipment and other stuff being developed with this program. This is the SLS rocket. Maybe in the informal discussions, I can talk about this more. This is Orion spacecraft, and this is the moon lander, so much bigger than the Apollo ones. And this is the gateway space stations that we plan to do on the circumlunar orbit. And these stations will allow human missions to be around moon for longer than the Apollo missions, so for about maybe 20-30 days. And from this station, there is a plan to go to the surface of the moon and back to the station, and from the station to back to the Earth. So that's the architecture of the entire system. This is one cool render of that station. It will be much smaller, of course, than International Space Station. And this is the plan for the Artemis 1 mission, the first mission that is uncrewed, and it is happening right now in 2022. Actually, there was already some ground test of the SLS rocket in April. There were some issues, so we are waiting for the second test, but the plan is that at the earliest in August 2022, there will be the first uncrewed test flight. So the first mission of new Apollo program, I would say. So the Artemis is like the new Apollo program. The first mission uncrewed will be 2022. And if it succeeds, we will see in 2024 first crewed mission with almost the same profile. So it will be circumlunar mission without landing on the surface of the moon. And this is the SLS rocket on the launch pad during these tests that I mentioned in April. And last things that I would like to talk about, I see that we don't have much time, so I will only briefly summarize how crewed missions look like now. So now we have two active crewed space stations on low Earth orbit. We have international space stations, and we have Chinese space station Tiangong. And the International Space Station is of course the biggest laboratory in space. We have experiments that use microgravity and extreme conditions on low Earth orbit. We have of course experiments in biology, biotechnology, medicine, physical sciences, earth sciences. This is more or less actual structure of the station. Okay, this is the countries that have some part in this scientific research in International Space Station. I won't tell about much of these breakthroughs. Maybe let me tell you about this Bose-Einstein condensate. It was actually very interesting because it was done 20 years ago, I believe, or even 30 years ago on Earth. But in 2018, this Bose-Einstein condensate was done on orbit. And it can be very, for physics, can be very beneficial, because we have like microgravity environment on orbit that allows us to, we don't need to, how to say that, we don't need to limit this condensate using some electrical fields or some optical means, because we have this microgravity. So that allows us to study these quantum properties of this Bose-Einstein condensate for much longer period of time. So that's why scientists very like this idea to bring that quantum research on board International Space Station. And of course, it's not the only one quantum research that it's done on Space Station. We have detectors that are working for astrophysicists for pulsar and black holes research. And it's why it's good to have them on the International Space Station, because we can have them repaired on International Space Station. And it was actually done with the IMS instrument that looks for the antimatter. There were, I think, 5 spacewalks that were dedicated to replace some components of that payload. And we have Tiangong Space Station. This is Chinese space station that construction began in 2021. In 2022, so in this year, there is planned 2 more missions that will bring 3 main modules to the station. And we already had 2 crewed missions to that station. So currently it's not occupied, but in June there is another mission that is going to the Chinese space station. Of course, we have James Webb Space Telescope, but as I predicted, I won't have time to talk more about it. I really encourage you to read more about it in Urania. I think first issue in that year, on the last issue on the last year, was dedicated to this space telescope. So this was like our main subject. We have article from the scientists that will work on the James Webb Space Telescope data. So they bring their science perspective, how they will use that data. And I wrote an article about more technical aspects of that telescope, how it was sent and where it was sent. And this is the first photo that this James Webb Space Telescope created. And Poland in space. So one slide, symbolic, but it's very important to know that we are developing capabilities on space. Actually, mostly commercial businesses, not government, but still we can be proud of student teams, for example, from University of Technology in Warsaw that developed satellites PeWSat 1 and PeWSat 2. We have in Krakow, we had satellite, also KrakSat, created by the students of many universities. And Poland is a part of European Space Agency since 2012, and this year really allowed this membership really allowed us to take part in actually almost all of scientific research that is done in space by the European Space Agency, and we hope that it will be better in the next years. And okay, I think I made it to the end, so thank you. I am stopping sharing my screen and waiting for some questions if you have.
Thank you very much for your lecture. I await a flood of questions. If you want to ask something, please raise your hand.
I see one thing about Iridium. Yes, there is Iridium Next constellation that was launched, and actually it was launched by the Falcon 9 rocket.
What are you talking about? I don't see any question asked.
I see in the chat. It's not a question actually. It's information from Marcin Pomorski.
Yeah, but that was a long time ago. So let us first await questions.
Okay.
Mhm. No hands risen.
I see one hand.
So then I have it delayed because
Frau Lee Tae-hun.
it hasn't appeared on my screen yet. Okay, now I have it. Yes, please, Tae-hun.
Actually, say several years ago, European space agents have a Mars mission. They tried to send the people, like around 25 people, in allowed to live in the Mars independently. I don't know. I haven't heard actually any news from those missions, because it's actually approaching the time they will send people settling in the Mars in around 2025 or 26 or sometime, but I haven't heard any news since then. Can you explain what's going on?
Mm-hmm. So probably you mean this project, American project that was called Project Mars or something like that, I guess.
No, European Space Aid. Actually, they recruit.
No, I don't know, and there was no such plans for the European Space Agency to send people to send crewed mission on Mars. So the things that the European Space Agency do now is sending uncrewed probes to the Mars. So we have like ExoMars project currently run, and ExoMars project is divided in two parts. So first part was done already. It is trace gas orbiter. So this was orbiter that is dedicated for the atmospheric research of Mars, and it's still working. And as part of this mission, it was also lander, Schiaparelli Italian lander that tried to land on the surface of Mars, but it failed. So we had this mission, and the second part of the ExoMars mission is European rover that is called Rosalind Franklin, and this rover was to be sent in the next possible window. So I guess it is this year. It was meant to be sent this year by the Russian rocket Proton and using the Russian lander Kozochok. But of course, after Russia aggression on Ukraine, this commitment, this collaboration was cancelled. So now European Space Agency looks for the ways that they can bring their rover that is already developed to the surface of the Mars. But realistically, we would have to wait for this mission until 2028 probably. So that's the current state of the Mars exploration by the European Space Agency. And European Space Agency won't develop Mars crewed missions by itself. If it will develop these missions, this will be definitely with collaboration with United States and under common program.
Mm-hmm. Thank you so much. I don't see any more hands. If you have a question or a comment, then raise your hand, please. Okay. No more.
I see Marcin.
You are clearly faster. Mine are delayed. Not yet. But okay, if whoever, yes.
Okay, I think I can go ahead. I noticed that you kind of didn't mention some of the Mars missions like Opportunity. Were they not interesting in scientifically, or did it just didn't make a cut for the presentation?
They didn't make it to the presentation because I focused on the missions that are currently active. So on these slides that I showed the missions, these were actually only the active missions that are on Mars. And as you probably know, Opportunity is not longer active, but from the science perspective, they were very interesting, and they did a lot of good research. it was in the time when I was not interested yet in the science, but they definitely bring a lot of knowledge to us, and they were first long time travelers on the Mars, because both Spirit and both Opportunity was planned to be run by for 90 days, but they were working for years, right?
Mm-hmm.
Yes, I think 90 souls planned, something like 5,000 souls working for Opportunity.
Correct.
Mm-hmm.
And the Opportunity actually ceased a few years ago. Yeah.
Yes, I mean, like 3 years ago, 4 years ago. Yeah.
Yes. Due to the dust storm.
Mm-hmm.
Yeah, and I think also battery was failing.
Yes, probably yes, because when you have like the long dust storm, it's impossible to, even if you go with the rover to hibernation, it's impossible to run all heaters. And these heaters that hits battery, if they don't run, this battery also degrades. So it was not possible to reactivate rover after that.
Okay, I don't see any hands up, so maybe you could comment on Marcin Pomorski's chat, which was given at the beginning of your talk. Could you read it aloud so we all learn it?
Mm-hmm. Actually, Iridium have recently replaced the entire constellation with second generation design. So I was talking about Iridium as an example of the business idea that didn't went well at first time, but yes, that's correct. The Iridium in this new space era created new satellites called Iridium Next, and they finished their entire constellation. It's working, and I think they're now economically fine.
I think it's also important to point out that the previous constellation was not deorbited, but following the bankruptcy, it was bought out at a very reduced price compared to development and putting them on orbit. And when you kind of subtracted this price, it was economically viable and actually financed the next launch in large part, and was used for the past 20 years, mostly on sea and for marine communications.
Yes, that I didn't know, but yeah, that's interesting that they were able to finance that from that first generation. And Iridium actually is also the type of company that maybe even were in the head of the the competition, because they were doing things like now space startups do things. So in the 90s, and they were doing that in the 90s. So that's the very good also example in their ideas.
Okay, thanks very much for this comment. Maybe anybody has a question or wants to add to this? My signals are clearly delayed, but I don't see anything. Right. So thank you so much for this lecture. Thanks a lot. And as we said, the lecture has been recorded, will be displayed at YouTube on our faculty channel. Thanks again, and have a good evening.
Thank you.